Alright, this is another video just to answer the questions or the next 10 questions from the 21 until the 30th question. So here we have a wave has the appearance shown. This is the wave and this is its appearance, displacements in meters against distance in centimeters. How do properties of the waves change as the distance from the origin increases? So we're going to talk about the amplitude and the wavelength. So the amplitude, let's compare between the maximums here, this maximum to this maximum to this maximum. As we can see, this is actually increasing in centimeters or as displacements. So the displacements or the maximum displacements is representing the amplitude. So here we can say that the amplitude is decreasing as the distance just increase. The wavelength, now what is the wavelength? As a definition, is the minimum distance between 2 points just like vibrating in phase. Let's demonstrate this just like this. We have this maximum and this maximum are actually vibrating in phase. This maximum also. So this is a wavelength, is a lambda. This is a wavelength, another lambda. Is this one equal to this one? It's clear this is a smaller distance compared to this one, which means the wavelength is increasing by distance. So the first choice or the option A is the answer to this question. Amplitude decreases, wavelength increases. The 22 question. A tank contains water. Ripples are bounced on the surface of the water. Refraction, this is a refraction, is observed. What causes the ripples to refract? Is it the cold water in the tank is replaced by warm water, or the ripples change speed as they move from deep to shallow waters? The ripples hit the wall of the tank. The ripples passes through a narrow gap. The answer for this actually is the B here. When we talk about the refraction means, as a definition already, a change of direction of a certain wave. When a wave is at a certain direction and it's changed this direction, we're talking about refraction. So the ripples hit the wall of the tank. This will cause what we call total reflection. That means it's going to change the direction to the opposite one. So it's not a refraction, but it's causing a reflection. The ripples pass through a narrow gap. This actually will cause what we call diffraction. That's a diffraction of the waves. So a linear waves will become circular waves after going through this narrow gap. So the answer here is the B. For the A, for sure, here in this situation, it will not cause anything. The diagram shows a plane mirror and a ray of light reflected from it. So this is a light coming into the plane mirror, and this is the reflected light. Which angle is the angle of incidence? As a definition, this is the angle. It's B. It's the angle between the ray and the normal or the straight line normal to the plane mirror. So we all the time compare angles to this straight line, which is perpendicular to the surface of the mirror. So the B is the angle of incidence. If, for instance, we want to talk about the angle of reflection, it's gonna be the C. But for this question, the answer is B. The diagram here the diagrams each show a ray of light from an object O, this is the O, passing through a thin converging lens. The principal focuses in each diagram are labeled as F. Which diagrams are correct? Just like applying the rules of forming an image made by a converging lens, we all know that the rays just passes by the center of the object of the lens. It will not reflect. It's gonna just be the same as its incidence before. So this one is correct already. This one, what's the problem of this one is just we know when an incidence light come into the lens parallel to the optical axis, it must go through the principal focuses here. That's what makes it false. So this one is not correct actually. The correct thing for this situation is that it's respecting the rules, which means if a certain incident ray come into a converging lens passing through the principal focuses, that means it will emerge with a parallel way to the optical axis. That means the 3 is correct also. So 1 and 3 only are correct, but the 2 it's not. So where are the 1 and 3? 1, 2, 2, 1 and 3. That means the C is the answer. Which row is correct here? Frequency of infrared waves compared to microwaves. Use of infrared waves here. The frequency of infrared waves compared to microwaves is greater actually. If we just come to this image here, it shows everything. This is a scale, or this is a diagram showing the different type of electromagnetic waves here. We're talking about infrared and microwaves. Those are the microwaves, those are the infrareds. Infrareds are in order of 10 power 14 hertz, and the microwaves are in the order of 10-12 hertz. That means it's gonna be greater. It could be A or B. The use of infrared waves, it's actually used in a radiant heater, just like what we use in microwaves to make or to cook our food. The satellite television are in these ranges or in these areas. So the question has an answer of A. The 26th question, a student investigates sound wave from a loudspeaker. The frequency of the sound wave is 25,000 Hz. The student has normal hearing, but she cannot hear the sound. What should she do if she wants to hear the sound from a loudspeaker? For sure, we all know the domain of hearing of a human ear is between 20 Hz and 20,000 Hz. That means inside this range the sound could be heard by a human. Outside of this range it couldn't be heard. This is an infrasound and this is an ultrasound. So the frequency used by this loudspeaker is 25. That means it's in this area. What does the students must to do is just to decrease the frequency to be inside this range. Let's look for this proposition here. Decrease the amplitude, it's not gonna work. Decrease the frequency is what must be done by the students, so she can hear the sound from the loudspeaker. The 27th question. Two isolated metal spheres are both negatively charged. So they were isolated, or they are isolated, and they are negatively charged, both of them, with the same type of charge. So the spheres are brought close together, but do not touch. Which diagram shows the charge distribution on the spheres? We all know the like charges repels and the unlike charge attracts. So this simple phrase can lead us to choose the D, because the both of them are charged with like charge, which is negative charges. That means the distribution of charges would be repelled by each other. Now the 28th question. When a plastic cup is placed next to a small piece of aluminum foil hanging from a nylon thread, the foil is repelled by the cup. So there is repulsion again. Why is this? So the cup is charged and the foil is uncharged, or the cup is uncharged and the foil is charged. The cup and the foil have charges of opposite sign, or finally the cup and the foil have charges of the same sign. It's the similar thing with what we have told in the previous question here. There is a repulsion. That means it leads us to think about the same type of charges. So seeing that means the D would be the answer for this question. The cup and the foil have charges of the same sign because they are repelling each other. The 29th question here. The diagram shows a piece of metal resistance wire. Which wire made of the same metal has a smaller resistance? So let's just remember the resistance equation. It's the rho resistivity times the length divided by the sectional area. Sectional area means the radius or the diameter. So here we're looking for the same type of metal with the smaller resistance. What would be that? Is it a wire of the same length with a large diameter, or a wire of the same length with a smaller diameter, a wire of greater length with the same diameter, or a wire of greater length with a smaller diameter? As we have said, we said before, it's the resistance is proportionally related to the length, but it's inversely proportional to the sectional area or the diameter. That means as much as we increase the diameter, the resistance would be less. So larger diameter will lead to a a rod with the smaller resistance here. The answer would be A for us here. Finally, for this video here, we're going to talk about this electric situation or electrical situation here, which labeled components in the circuit shown controls the brightness of lamp X, this lamp X. As we see here in this branch, the only thing that we have are the lamp and this variable resistor, which means what's going to control the lights or the brightness of this lamp is just this components labeled by B. This is the answer for this question, and for sure if you do have more questions you can just drop them in the comments. And as I say all the time, don't forget to subscribe and just like the video, so like that we can do more and more in this channel. See you in the next video, where we're going to talk about the next 10 questions in this paper of this version.